Alright, so I'm going to walk through this process. I'm going to talk through you guys' process, so if I say anything or say the wrong stuff, you guys correct me. So for Javier's problem, it looks like he changed the denominators so that they would be the same, making them both 6. And then subtracted the 2 and the 3 to get negative 1/5, and the 4 and the 3 to get 1/6. And then multiplied by the reciprocal of the denominator to both the top and the denominator. And then this was close, but these would have canceled, yes, and this would have became negative 6 over 9. But everything else was good. So negative 6 over 5 was your answer to number 8. Any questions on that one before we go over 9? Eric, you did this one? Okay. So for Eric's problem, he set this up and then changed. There's like a lot happening, so I'm going to talk one step at a time. Change the mixed numbers to improper fractions, 8/3, 9/2, but then also change these whole numbers to fractions, 2 over 2, 9 over 3, so that they would have the same denominators. And then subtracted, so 9 minus 2 gave us 7, 9 minus 8 gave us 1, and then multiplied by the reciprocal, that's 3 over 1. Multiplied across here, and we got 21 over 2. And either of these answers was fine, just make sure you put them equal. Any questions on that one? And then I think I did this one. For number 10, so these two mixed fractions. She changed them to improper fractions, 49 over 8 and 3 over 2. And then, I don't see this up here, but she may have did this for her calculator. That's okay. So if you set this up like this and do the rest in your calculator, that's fine. I just need to see how it's set up. So if you would, from your calculator, you would get 33 over 8. So you would have to, if you're doing it by hand, get a common denominator and then simplify them. But you would still get 33 over 8. Same thing with the 3, you would have to get a common denominator and then subtract them, and you would get 3 over 2. In all of our other examples, this was like a 1 and something, so they nicely canceled out and you didn't have to multiply like 2 things, but in this case that was not the case. So you did have to flip this, multiply by 2 and 3. If you put in your calculator, you got 11/4. When I multiply fractions like this, I look and see is there anything I can simplify as I'm multiplying. So this is just me in my head. I know that 2 goes into 8 4 times, and 3 goes into 33 11 times, so that would also help me simplify it. But 11/4 was the answer to that one. Questions on that one? So like I said the other day, the process is really the same, it's just a little bit more tedious because of the fractions. Okay. We are going to move on to this next page. So far we talked about slope from a graph, slope from the point. This next part is kind of slope from the equation. So when we start writing equations and when we start graphing equations, they will all be in this form, slope-intercept form, y equals mx plus b. So if we think back to when we were finding our intercepts and it was f of x equals some number times x plus or minus some number, it was in this format. That's why we could easily find our y-intercept. Because our m, as we already found out, is our slope and our v is our y-intercept. So anytime your equation is in this format, you will always know what your y-intercept is. The number in front of x will be your slope. So in these examples down here, you're given the slope and given the y-intercept. You just have to put those two together in this equation. So for number 1, all of these have to start off y equals. Our slope would be 2. I need to put in my x, and my y-intercept is -1. So even though it says plus b, that doesn't mean it has to be a positive. It's whatever the y-intercept is. How would I write number 2? And you guys can say it out loud.
Y equals negative 3/5
Y equals -3/5 x plus 4. There we go.
Does it matter if the slope comes after the y-intercept?
Give me an example.
Like if you put y equals 4 minus 3/5 x, would that be the same thing?
That would be the same thing. I will say that we want the slope to come first since it's in slope-intercept form. This would not be an incorrect because it would be the same, but we just want it in that specific format. Okay. How would we write number 3?
Y equals -3x plus 4.
Plus 4?
Plus 2.
Plus 2. There we go. Number 4. Negative x. Yeah, you can just write negative x. You can write -1x, but again, you won't see that -1. Number 5. You can put plus 0, you can leave the 0 off. You will see it without the 0, but you can definitely put plus 0 to help you remember that it has a y-intercept of 0, so either or. And then the last one,
Y equals -5/2 x minus
3. The bottom part of this is really, it really shouldn't be there. When we get into writing equations, that's what that bottom part is really for. Just for practice purposes, we'll find the slope and y-intercept of these graphs and write the equation, but this part will be more for our next unit. So the y-intercept is easy because it's wherever it crosses the y-axis. Where would that be? -4. Your slope, remember, you have to count.
rise and run.
Your rise over run, yes. So it's +3 because it's 3 over 1.
So then the equation y equals x minus 1.
Correct. Same process for number 8. What would your y-intercept be? 7. Your slope, you need to count your points. minus 6 over 4, and 5 and negative. Yes. So our equation would be
Y equals negative 3 over 2 plus
x plus x. Always remember your y equals and remember to put your x. If you don't have those two things, you're missing pieces. Okay. And then on this page is the actual lesson for today. So this is the last thing we need to know about slopes. We already know how to find it in an equation. It's whatever number is in front of the x. But sometimes it's not written in slope-intercept form. Sometimes it's written in standard form, which is this ax plus by equals c.
What dark magic is this?
So when it's written in this format, we have to do things to the equation, solve it so that it's back in our slope-intercept form. Right, so we're going to go through a few of these together. At first, it may be a little confusing, but just work with me. So we're going to solve this like we would a regular equation, as if we're trying to get the variable by itself, which we are, but we have two variables, and we're only focused on getting y by itself. So we're going to pretend that 2 and x are one whole term that stick together. I don't separate them. And I'm just trying to get it away from y. So for this one, if I wanted to get y by itself, I would get rid of this by subtracting it. So we're going to subtract it to the other side. And I'm going to kind of move it next to 3, not like right underneath. Because these are not like terms. I can't combine 3 and negative 2x. One has an x, one doesn't. So when I do this, these cancel. I have y equals 3 minus 2x. Because really I'm just bringing it down. I'm rewriting it. I'm not actually subtracting it. And then to get it back in slope-intercept form, I need to switch these two. So it's still going to be negative. Your signs stay the same.
You add
And you add.
Dark magic.
So with that one, it was one of the simpler ones because there was just really kind of 2 steps because you had to switch it. In the future, you can switch it right away instead of writing it as 3 minus 2x. Let's do an example like number 2. We're going to start off the same way, getting the x term away from the y term by subtracting. And when I rewrite that, I'm going to go ahead and switch these two now so I don't have to do it later. So I'm going to write this as negative 4x minus 30.
Normally we do multiple y's.
Is there an example like that? Oh, you're talking about because it has 5. We'll do that in 1 second. So in a normal equation, if we're trying to get y by itself, what would we do? Divide by 5. So we're going to do the same thing, but we're going to divide each piece by 5. So that this becomes just y. Negative 4 over 5 does not simplify, and you want to leave whatever that is as a fraction. And then negative 30 over 5 would just be negative 6.
Is the x on the outside of the fraction?
It really doesn't matter. You can put it here, you can put it up here. Either one. So in each one, subtract that x term if it's positive, divide whatever number is in front of the y, and switch the order if you need to. Is really all we're doing for all of these. I'm going to do a couple more. Before we do number 3, does anyone have any questions on how we got that so far? Yes.
So when we try to divide it, we always do yields to the opposite of x.
Yes, always do the opposite of the x. So if it's positive, subtract. If it's negative, add. Abina.
If the fourth is were to simplify, can it be a whole number?
Say that one more time.
If the fourth is, so if it doesn't simplify, say the fraction?
Yes. Remember, slope can be a fraction, that rise over run. It's okay if it is. Leave it as a fraction, whatever it is. Do not put decimal as your slope. You can have the decimal as your y-intercept, but leave your slope as a fraction. For number 3, we're going to do the same thing, same process. Start off by subtracting x to the other side. Now we have a negative 3y. I'm going to go ahead and switch these two so that I have negative x first. And now we're going to divide each number by a negative 3. So remember that your signs are most likely going to change. Your y would become a positive because you have two negatives. This would become, remember there's really a 1 here, so this would be positive 1/3 x. And then this would become a negative 4.
So the x, it wouldn't be 12 x, it would be x, the negative x.
So if you wrote it like that, it's fine. But at the end, you would need to change it back. If you didn't write it like this and maybe kept your x in here, in your fraction, and wrote it like x over 3 minus 4, that would also be okay. We're going to do one more example together. Number 7. How would we start number 7?
Subtract 6x.
Would we still subtract it?
No, we add it.
We would add it because this one is negative, so we would do the opposite. That's okay. I'm going to go ahead and switch these two. What would we do from there?
Divided by 4.
Yes, to each piece. So y equals 6 divided by 4. Can we simplify that? 3 over 2. X, 20 divided by 4 would give us 5. So altogether in slope, you will need to be able to find it from a graph. Find it from 2 points. find it from an equation, which could be in slope-intercept form or in standard form. I'm going to give you the next 10, 11 minutes, 11 and a half minutes to do the remaining problems on here, 4, 5, 6, and 8. And then we'll go over those. And then after that, you'll have time to work through your Khan Academies, Delta Math, for intercepts and slope. And then if you finish all of that, I will let you have time to yourself. But before Khan Academy and Delta Math, in the next 10, 11 minutes, do those 4 problems. For those 4, I'm going to show you the answers to those. Starting with number 4. I think I missed it in the directions. It did say something about like identify the slope and intercept, and I did not do that. If you went back and did that, that's fine. If not, that's also okay. Really, I just need to know that you have your equation. For number 4, your equation should have been y equals x plus 8. Number 5, we didn't do that one, was y equals 4x or 4x plus 0, either or. 6 was y equals 3 over 2x plus 7. And 8 was negative 1/5 x minus 3. I'll slow down this a bit. Yeah. Do that one more time. I have a first part of it said, could you have done negative x or what? Does it have to be 1? Like here? The bottom part? Yeah. If you wrote it as negative x over 5 minus 3, that would also be okay. Do we have any other questions on those 4? So for the remainder of class, you have different things to work on. There are 2 Khan Academies for intercepts due on Friday from a graph from an equation. The Delta Math for intercepts was already due, but you can still work on that. You have 3 Khan Academy for slope, 1 from a graph, 1 from 2 points, and then slope-intercept intro, which is really, do you know which one is the slope or the y-intercept? And then there are 2 Delta Math. One is part 1, which is slope from a graph and slope from 2 points. The other one is kind of like slope-intercept intro / converting what we were doing today. Both of those Delta Maths are due by next class, so that is Wednesday will be the next time I see you guys, because you guys don't have school Monday and Tuesday. So you have a multitude of things to work on. If you are finished with all of those things, then you can work on other schoolwork / grab your phones, but ask before you do that. If you have questions on any of those things as you're working, I'll be around. Ask me, we can go through it together. But the remainder of class is yours to work on practice.